Okay, 6.3 day 1, we're introducing the definition of a logarithm. Okay, this is the definition of a logarithm with base b. It says let b and y be positive real numbers with b not equal to 1. I will tell you why not in a second. The logarithm of y with base b is denoted by log base b of y. That b is a little bit lower and it's smaller, and is defined as the log base b of y equals x if and only if b to the x equals y. Okay, these are equivalent statements. This is a logarithmic statement. This is an exponential statement. They mean the exact same thing, but sometimes it's more convenient to write it in this format instead of this format. Okay, I'm going to go back to the beginning where it said b and y are positive. What is it? No, actually, b can't equal 1. They say b can't be 1 because if we do 1 to the x, we just get 1, which makes it a constant function. We want b and y to be positive just because if the base is positive, this is going to be positive. If this is negative, everything gets messed up. Okay, so to start off, we're just going to practice converting between the logarithmic form and the exponential form, and this is the most important thing you need to know about logarithms. Okay, so in this table, this is logarithmic form. The way I say this is log base 5 of 125 equals 3. Okay, I'm going to rewrite an exponential form, which is going to look like this. Okay, so this is log base 5. So this is the base. This is the base. So when I rewrite it, the base is 5. Okay, this says b to the x. Whatever this equals to is the exponent. So this equals to 3. Logarithms are the exponent. So it says 5 to the third equals, and it equals to y. Y is the argument, which is the 125. 125. So I get 5 to the third equals 125, which is true. 5 to the third is equal to 125. So this is exponential form. This is logarithmic form. They mean the exact same thing. They're telling you the exact same information. Okay, let's try the next one. Okay, log base 7 of 1 equals 0. The base is always the small little number. So when I rewrite it, it's a base of 7. It always equals to the exponent, so this is my exponent, because logarithms are exponents. And the argument is what my exponential equation is going to equal. So 7 to the 0 equals 1. If they're numbers, when I start it at the end, it should make sense, make a true statement. Okay, let's try the next one. What's the base? The base is the 8. It equals to the exponent, so 8. The exponent is the negative 2. And then this equals to 1 over 64, which is the argument. And 8 to the negative 2 is 1 over 64. So both statements are true. They're just written differently. Okay, now I'm going to give you the exponential form, and we're going to go back and write the logarithmic form. Okay, since I want to write it in logarithmic form, I'm going to say log. Okay, the little number that goes here is the base. So the base of the exponent is the 3. So I'm going to write 3, and the 3 should be small and low. Okay, the number that goes here is called the argument. It's whatever this is equal to. So this is equal to 342. So I'm going to put the 342 here. And logs equal exponents. So the exponent of this equation is the 5. So I put a 5 here. So this is saying the log base 3 of 342 is 5. You know what? That's not true. That's 200. Isn't it 200? Hold on. It's 243. I will fix that. Okay, I magically fixed the typo, and I will fix it before I print it. Okay, let's try the next one. Okay, log base. What's the base? The base is the number that the exponent is being applied to. So the log base 6 of this number equals the exponent. Okay, one more. Log base. The base is the 1/4 of the 16 equals the exponent. Okay, now I'm going to tell you about two specific kinds of logs that are useful because they're on your calculator. So the first one is called a common log. It's a logarithm with a base 10 is denoted by log, meaning if it says log and there's no base indicated, the base is 10. Your calculator knows this log, which is why it is a commonly used form of log. The other type of log is called natural log. It's a logarithm with a base of e. We learned in the previous section E is 2.7 something something, and it's a very common constant in science and finance. Okay, it's denoted by ln. Now let's see what that means. So this is my logarithmic form. It says the log of 100 is 2. There is no base indicated. Normally the base is right here. If there is no base right here, that means my base is 10. So I say 10 to the exponent equals the argument. Okay, so if there's no number written at the base of your log, it means it is base 10. And it's called common log because it's the most common log in because your calculator knows it. Okay, now the next one says ln of x, which doesn't look like log, but it actually stands for natural log. Natural log is a logarithm with the base of e. So it does not denote a base, but if I see ln, the base is automatically e. The exponent is what it equals to. And then this equals to, in this case, there's a variable here, so it equals to x. That's how I would rewrite it. Now let me go backwards and do the opposite. Okay, so I'm gonna rewrite this in logarithmic form. So I'm gonna say log. Okay, and then we normally put the base here. The base is 10. If the base is 10, you don't have to write the 10 here. So you could leave the 10 off. Log base 10 of, what is it, 1,000? Is equal to the exponent. The exponent is 3. So that little 10 there, you can write it. It's not wrong. You just don't need it, so I could erase it. Okay, last one. It says e to the 5 is 148. The base is e. If the base is e, instead of writing log, I'm going to write ln. Okay, and then ln of 148 is equal to the exponent. The exponent is 5. Okay, now we're going to evaluate some logarithms, and we're going to try to do it without a calculator. No, we are going to do it without a calculator. We're going to try to do it in our head, but I'm going to show you off to the side what I'm actually going to do. I want to figure out what the log base 6 of 36 is. Okay, so this is going to equal to something. I'm going to put a question here for now, but eventually you're going to do this in your head. Okay, I'm not going to, you don't have to rewrite it exponentially, but exponentially, this is telling me that the base is 6. The exponent is a question mark, and it needs to equal to the argument, which is 36. So it's saying 6 to the what is equal to 36. It's 2. They're just asking what is the exponent if the base is 6. So I put 2 here. And that's because the base is 6. This is the exponent. If I do 6 to the second, I get 36. If you can do that in your head, I'm fine with it. I'm going to write it on the side for people who find that helpful. Okay, if you're trying to do this in your head, this is the base. This is 2. This should be the exponent. This should be what I get. So if you can do it in your head, you can write the answer. If not, down here I'm going to say, okay, so base is 2. I don't know what the exponent is, but it should equal to 32. So 2 to the what? 2 to the 5. Okay, I'm going to keep going. And you can try to do them in your head. I'm okay with that. But this is little numbers, the base. The answer is the exponent. So I'm saying 4 to the what is equal to 4? 1. Okay, next one. Base is 3, so 3 to the what is equal to 81? 3, 9, 27, 81. So 3 to the 4th. So the log base 3 of 81 is 4. Okay, base is 8. I am trying to find the exponent because the log is an exponent and it should equal to 1. What exponent is going to give me an answer of 1? 0. 8 to the 0 is going to give me 1. Always going to be 0 if I'm trying to log 1. Okay, log of 100. It does not give me a base. So what's the base? 10, because this is a common log. So this is saying 10 to the something equals 100. What's the exponent? 2. Okay, now I believe you could do most of those in your head. I think some of you can do this row in your head too, and some of you can't, and I'm okay with it either way. Okay, the base is 5. I'm still trying to figure out the exponent, but this time it's going to equal 1 over 25. Okay, you're going to think. Okay, to get 25, that would be an exponent of 2. But since it's at the bottom, what does that do? Negative 2. The negative moves it to the bottom. Okay, so 5 squared is 25. 5 to the negative 2 is 1 over 25. Okay, so when I see a fraction, I always think that. So the same, if you do the log base 7 of 1/7, if you can do it in your head, that's fine. If not, the base is 7. What's the exponent that gives me 1/7? Okay, well the 7, it's a 1, but then it flips, so it's a -1. Okay, what is this? Log base, oh, no base, so what's the base? 10. Okay, and then I want to get 1 over 1,000, so what, to get 1,000, that's 10 times 10 is 100, times another 10 is 1,000. So 10 to the third is 1,000. If I wanted 1 over 1,000, -3. Okay, now I think everyone could do first row in their head. Second row, some of you could do. Third row is going to be the challenge, but we can still do it. Okay, the base is 36, so the base is actually bigger. 36 to the something gives me 6. What the heck? Okay, so what do we do to 36 to get 6? We square root it. Okay, so if I square root 36, I get 6 because it's getting smaller. What exponent represents square root? 1/2. Okay, that's square rooting. If the number is getting smaller, it's probably getting rooted. You need to figure out what kind of root and then rewrite it as a fraction. Okay, let's try this one. So 125 is the base. I don't know what the exponent is, but my answer gets smaller. It goes down to a 5, which means it's probably being rooted. Can I square root this? No. Can I third root this? Yeah, if I do the third root of 125, I get 5. What exponent is a third root? 1/3. Okay, this one has a star because it's hard. Base is 9. Exponent. Okay, I'm trying to get 1/3, which has, it got smaller and it got flipped. So I'm going to say it is going to be a negative. Well, I don't know what just happened there. Okay, it's going to be a negative because it made a fraction. But how did I get the 3? I square root 9. So if I square root 9, I get 3. But then to make it go to the bottom, I had to make it negative. So this should be negative, and then the square root is the 1/2. Okay, and that's a harder question. Eventually we'll learn another way to solve this rather than just doing it in your head. But for now, that's a good way to do it. Okay, the last ones are involving common log. Okay, common log and natural log. We use these when we can't get an exact answer because our calculator knows common log. So I'm going to use a calculator to do the log of 135. If I tried to do this in my head, I would say 10 to the something equals 135. And there is something, I just don't know what it is. So on your calculator, there should be a button that says log. You're going to find the little button that says log, and then you're going to press log 135, and you're going to hit enter. Okay, you should get, this is approximation, it's not an exact answer. How many decimals? 3. So 2 point, and I'm going to keep 3 decimals. 130. Okay, this is saying if I do 10 to the 2.130, I would get 135 as my answer. And that seems reasonable because 10 squared is 100. So I need to be a little bit higher than a 2. Okay, the next one says 5 log 3 over 4. Okay, try to type that in your calculator exactly as it looks. I'm going to tell you the answer so you can see if you're getting it right. It's not an exact answer, so I'm putting the little curvy approximates. Okay, I got negative 0. I'm going to keep 3 decimals. 6, 2, it's 4, 6. I'm going to round it up to a 5. Okay, on your calculator, let's see, you probably are going to type 5 log. Depending on your calculator, you might need a parenthesis, and then a 3, and then like a slash, or you might need a divide. 4, and then a parenthesis. Try it like that. Sometimes you have a slash instead of a divide. Okay, the last one's ln of 14. There is a natural log button on your calculator. You just need to look for it. It's ln 14, natural log of 14. Okay, I'm putting in my calculator. Okay, and then I got approximately 2.639. I'm keeping 3 decimal places. That's not exact answer, but it means that e to the 2.639 would be about 14.